because that's what you have taught in the class. So then he started explaining something that really stayed to me or till this point of time. And probably if you have seen my videos, I have already shared it on LinkedIn a lot of times, quite a few times, that being a data scientist is like being a doctor. Understanding data science is like approaching like a patient with a doctor mindset. Okay, like how is the relationship? It's basically you consider data as your patient and you are the doctor. And so when you let's say when a patient goes to the doctor, let's say I am sick, and when I go to the doctor doesn't like really instantly give away, okay, do this test, do this test, do this test. He tells like this, or he instantly goes and tells you that, hey, okay, tomorrow it's a surgery day, okay, because you have something here, or just go and have that medicine right away. Yeah, some doctors does that, but if you see advanced disease, it doesn't work like that. What does the doctor do? Doctor checks the basic things like heart, like pulse bit, and then he checks tongue and stuff. He checks how much fever do you have, and that's also basic things we do at home before going to the doctor. If you have fever, we go to the doctor. So as you can understand, these models and all these fancy things are like those advanced surgery. They are very important if there is a problem, and probably you need that. Of course, you need that. That's why I've gone there. Like for advanced diseases, you need a surgery, but to understand the method of surgery, to understand which surgery and how to plan it, you need pre-test, right? Some pre-processing or pre-understanding of the data, what's going on. So that's why my topic today is to make you understand how to start a data science project, not how to do a data science project. Okay, so that's a difference to it. So this is a wrong approach. And then what is the correct approach? Okay, that's the like a natural question. So when you get the data set, guys, when you get a data, understand the data is being collected by some person, and that person has a goal. So data never comes alone. Data comes with a goal. So the difficulty is that when you get a data set, you are confused, or I was confused, or probably you were confused before, is because you don't know what the goal is. So what do I mean exactly by the goal of a data set? What do I mean by exactly a goal of a data? So there are two goals, very, in a very broadly speaking manner, there are two goals. One is supervised learning, or one is unsupervised learning. So if I ask you, like if I talk about a bit about what is supervised learning, it's simple. So you have a data set. So let's assume the data set is expressed in a tabular form, and you can divide the data set into two halves. One is like probably there's one column for the response variable, and there's another column for the predictor variable. Okay, set of columns. And the question is that given this data set, if I give you a new set of predictor variables, what will be the corresponding response variable, which you don't know? That's the whole purpose of supervised learning. Let me explain you once again. There's a set of predictor variables, certain columns out there, and there's a response variable out there. So the question is that if I give you another set of predictor variables to which you don't know the response variable, can you find the response variable? So this is the question, that this is a goal of supervised learning. All of you understood supervised learning? Yes or no? You can say yes in the comment box. Okay. If you have doubts, you can please ask me. Raise your hand and ask me. If you understood, please say yes in the comment box. It helps me to understand and connect to you guys. Yeah, thank you. If you have some doubt, please ask me, guys. I don't want my students or people I'm talking to go out of the class or whatever discussion without understanding something I'm sharing. Great. Super. Okay. So let me explain it to you once again. So we have a data set. It's a tabular form data set. So you divide into two parts. Let's say response variable and predictor variable. The response variable is one column, predictor variable is the rest of the columns. And your goal is to understand that given a predictor variable, another set of predictor variables, what should be the new response variable? Rather, you can also ask it in this way, that it's same as asking, it's equivalent to asking that given this y and x, can you find a function which corresponds, which calibrates this X and Y together, which kind of tells a relationship with this X and Y together. And hence the goal is to find an F in an approximate manner. Okay. So I will tell you examples of this after telling you what unsupervised learning is. So unsupervised learning is same thing. You have started the data, but you have now columns of data, like, and you have no response variable. There's no concept of prediction here. Okay. So the goal of unsupervised learning is to find patterns, not relationships. So you divide into data like this, like columns of data. Let's each one of them is a feature. Okay, each one of them is a I will show you examples. Each one of them is a column of data. Okay. Now you take this data and probably you can for two such features you can probably plot them on a let's say if there are two features, two such x1 and x2, you can plot them on a coordinate axis, okay, on a 2D plane, maybe in a 3D plane too. So the goal is that when you plot them, you can see that some things tends to be together. Okay, some data sets are clinging to each other together, and some are not, or they're different such clusters. So the goal is unsupervised learning is to learn, is to understand, and is to find this corresponding similar behaving clusters. It's like one of the most important goal. Okay. That means in unsupervised learning, there are no predictors. There are features, and you try to find which features make set of features, not a set of features, a subset of features, a subset of data which are behaving similarly, and your goal is to find the clusters. Did you understand unsupervised learning, guys? The basic idea of it? Yes or no? Great. If you have doubts, please ask me, guys. You can raise your hand and ask me. Feel free to ask me. Okay. Do all of you understand that? Yes or no? If not, tell me. Okay, probably I will give an example. So let's say supervised learning example. So here is a data set which is called the wine data set. So now can someone tell me what do you think can be which is a good response variable, which are predictor variables? Can someone share his or her idea? Which do you think is a response variable, the y, and which you think is a predictor variable, the x set of x, if you remember this diagram? This one. Can someone tell me what is this corresponding thing here? Yes? Anyone? Anyone can raise his or her hand and start sharing his or her view. Okay, so if you divide, this is the data set, this is tabular form, and you can understand that this is equivalent, like you can see that the class identifier, the type of wine, the class identifier is nothing but a type of wine. And that is dependent on the X variable, the chemical compositions of wine, because different chemical compositions have different chemical compositions lead to different types of wine. So this is one example of a supervised learning where X is the predictor set and Y is the response variable, which is the type of the wine. Now, yes, the goal is to predict the type of wine from the chemical composition. Great. And an unsupervised learning example, simple. You just delete the y-axis. Okay, if you just delete the y-axis, not the y-axis, I mean the response variable, it turns out that this is an unsupervised learning problem. Now understand, you are given a chemical composition of, let's say, 200 wines. Okay, and you don't know the type of wine out there. So automatically the problem can lead to, so of course find that similar wines, like the same wine will tend to have same type of chemical composition. So you will get that similar wine are clustering together, similar type of wines are clustering together, are behaving the same way, and you are doing it without any knowledge of the response or the type of wine. And this is exactly the problem of unsupervised learning. So the difference between supervised learning and unsupervised learning is only in the type, like the difference in what the data set is and what is the goal is. Okay, did you understand, guys? These are letters and identify the different clusters of wine from the chemical composition. That's the whole point out here. So did you understand this, guys? What is supervised learning and what is unsupervised learning? Yes or no? Great. I showed on the basis of the same data set so that you get to understand what is the difference. What about others? You can say yes in the comment box, please. It will be really helpful for me to understand that whether you understood or not. Okay, great. If you have doubts, please ask me in the comment box, or you can just unmute yourself and ask me. That's great. Thank you. Super. So this was the first part of the discussion, that the data never comes alone. It comes with a goal, and the goal can be of two types. There's another goal called reinforcement learning, but that is I'm not interested to share about that here. Okay, the reinforcement learning is like a different thing. It's like how to train a robot to do some certain things. It's learning from experience. That's a different thing. So I will focus on today's supervised learning and unsupervised learning. So the next part of the lecture discussion is that. So okay, so after you have got a data and you have got a goal, so then what will you do after this? What's the next step? The next step is this, that it's all about data visualization. Now understand why data visualization is very important. This is something you should understand and you should feel it. The reason why I say feel it, because it's inside your own existence. So the most complex machine in the world is Dash. Can you say what is a Dash? The most complex machine in the world is Dash, like that human beings possess or human beings have around them.
Computers or human brains?
Okay. Yes. Computers, one person has told. Siddharth has told human brain, and yes, human brains is right answer. Computers are much, computers are lesser powerful in terms of something, but brain is the most important and most complex machinery in the world. And yes, human brain. So thank you for answering that, Siddharth. You're right. So now the question is that how can we use this complex machinery, or whether we are using this complex machinery to analyze the data set or not? Understand, we have five sensory, the five organs with which, five instruments with which we perceive the world around us. We collect the data from the world: eye, ear, nose, tongue, and I think skin. Yeah. So five perception we have, and the eyes are the most powerful one. So data visualization is nothing but using the complex machinery and the perception of eyes, the instrument of eyes, the model of eyes, and the machine of brain to perceive the data set. Okay. So we will therefore pull out and visualize the data set before proceeding and giving it or handing it over something, a machine that we don't know how it works. Okay, so that's the whole purpose of it, being using and trusting our own intuitions before giving it to machines. So that's the basic idea, that human brain is the most complex structure, and that's how you gonna use it right now. So data visualization is very important aspect. You're using machine learning algorithm. That's what my point is. We're using a machine learning algorithm, but the machine here is the brain, and the instrument or the model here is the eye. Okay. So now what I will tell you in the next part is that how to do a data visualization. Okay. So there are various structures. The question is that there are a lot of different data visualizations. Okay. You can see line plot, bar plot, bubble plot, tree map plot, contour plot, kernel density, histogram. You can find thousands and thousands of examples, and different people have developed different such structures, okay, such ways of visualization for their own domain knowledge, for their own purpose, for their own understanding. But you are a human being, you need to have, so understand whatever is being developed, only a small percentage of it is actually important, and the rest of it is garbage, or it's like it's very minute, very focus on a certain aspect, but not in general it helps you. So my purpose today is to help you understand this data visualization, the top 20%, the most important ones that can help you understand and get out better patterns and quality information from data. Okay, so there's a specific algorithm that you just need to do, and I will show you how to do it, and I will show you exactly the methodology to do it, and that's it. So understand that, as you can understand this very in a very core sense, that the two goals that I have discussed, supervised learning and unsupervised learning. The supervised learning is understanding the relationship of the y variable with the x variable, right? And find the by relationship, we model relationship by a function. For the unsupervised variable, so for the unsupervised learning, we are not finding a relationship. We are finding the behavior of the data. Okay, we are understanding the behavior of the data, whether the data is getting separated, or whether getting, like, which part of the data is behaving which, like, together behaving similarly. So therefore unsupervised learning, we will see it's mostly related to the behavior of the data set, and supervised learning we will see is mostly related to the relationship of the data set. Okay, so understanding, so let's say you have a data set and you have a data understanding. Let's say you are finding the univariate behavior. So essentially, so I will now it's time to show you examples. Okay, so just give me a minute. I'll just open it for you. Okay, so you can so let me show you some examples. So let's say probably let's come back here. So we are understanding univariate behavior. So we have two type of data sets, as you know, the type of data. One is numerical, one is categorical. So the goal is to understand the goal of this data visualization aspect, that you have a single row. Let's take this case. Let's take your understanding. So wine is made up of alcohol. So let's say you're using the alcohol as a column variable to understand how many different alcohol types are there. Means how many different wine types are there. So your intuition is that probably different wine will have different alcohol percentage. Okay, or that's your guess, like you're not sure about that. That's what you're asking. So that's why you need to understand that univariate behavior. Why I'm saying univariate? Because it's univariate data, a single column. Understanding the behavior of that to understand whether there are two different types of, or more than one different types of, or more than one different types of wine or not. That's the goal. Here alcohol is numerical. So what will you do when it's a numerical thing, when it's a numerical variable, a single numerical column? You essentially do this three type of things: kernel density, histogram, or box plot. But I will say kernel density is the most important thing that you will see, and very useful thing that you will see for understanding this unsupervised behavior, the clustering aspect. And for categorical, you will see bar plot. So now let me show you an example. Let me show you an example now. So for that, I need to share my screen once again. So observe that. So let's go back to this univariate thing. So let's take this univariate visualization called kernel density. So what is the kernel density? Kernel density is nothing but it's a format of just give me It's nothing but a histogram, but I don't know if you have learned kernel density in your masters or not, but essentially it's nothing but a mixture of normals out there. I'm telling this more to you because probably we'll connect it, okay? And trying to find that mixture proportion of the normals, okay? So observe from here that magnesium, the distribution of magnesium probably tells you that it's a single cluster. Probably the magnesium leads to the understanding that probably there is only one type of wine out there, okay? So magnesium tells you that there doesn't seem to be more than one clusters based on this magnesium feature. But if you take flavonoids, let's say, now flavonoids tells you a different story. Flavonoids tells you the story that probably there are more than one clusters. Probably there are two clusters. And if you have learned Gaussian mixture modeling, I don't know if you have learned it in your college or not, this essentially attacks this problem and find out which are those two clusters and finding out boundaries out there. Did you guys learn about Gaussian mixture modeling in your college? So since you guys are masters, I'm asking about these things because probably you've learned it. Yes. Like this, are these data science topics taught? Okay, it's not taught. So if you learn it on your own, you will probably understand that it's fun. But essentially the goal is that this whole data set tells you that flavonoids tells you that there are probably two different type of wines where it's coming from, because you see two different type of behaviors. They cannot come from the same wine, right? So the clustering behavior are same, so they cannot come from the same wine. While magnesium tells you that it probably there's only one feature. So you can instantly understand that magnesium is a bad feature for expressing the clustering thing, while flavonoids is a better feature for explaining the exploiting and understanding the clustering, the behavior, the similar behavior. Did you understand this, guys? This univariate behavior, guys? Yes or no? That how this univariate behavior is giving you understanding and insights into the data set. All of you. What about others? That's great. Thank you. So therefore, that's what I mentioned to all of you, that the univariate behavior is a very important step in understanding clustering, in understanding how the data sets are behaving together. So let's see if there are other more things or not. So I will come to this later on. Okay. So understand, histogram doesn't tell you a good aspect or a good understanding, because it's not showing two clusters, it's showing you two behaviors, but it's not showing exactly maybe there are two clusters or more than two clusters. So histogram is not really, for example, you can misinterpret that there are probably two clusters out here. Actually, there are two clusters, but they are so close together that you will not be able to understand. Okay, you're not being able to distinguish by your human brain, the machine of the human brain. Okay, so now let's go back to the next part. Similarly, you can understand the same thing. You can understand the behavior of this whole categorical thing by the bar plot. Okay, so I have not done any example because it's not really interesting. So I'm showing it the univariate case, the continuous numerical case, so that you get an understanding of it. Okay, let me go back to the presentation. Okay, so this is what the first step is all about. Okay, so this is a very a stored tree diagram and a decision for you, a decision tree like you, for to do this simple steps and understand the data set. That's it. Okay, and no more complicated things like you need to do. This is the first step you should do. Okay, no complicated things. Okay, so now bivariate behaviors. Essentially, it's taking in two variables out there and try to see the same thing, whether they are grouping up together or not. So how to do that? So essentially, for numerical versus numerical, it's not scatter plot. So I will show you what scatter plots look like and why you shouldn't do that. It's not giving any information. So let me show it to you. So as you can see, for numerical versus numerical, you should do bivariate density plot, because also you can plot the scatter plot for numerical versus numerical. Okay, but here we'll do bivariate density plot. There's a reason for that, and you will see. I will show it by example. For categorical versus categorical, you will do group box plot. Okay, what is the group box plot? I will show it again. And for category versus categorical, you will do contingency table or contingency heat map. But these things are, I will show you these examples one by one, okay? But for category versus categorical, it comes up really less, so it's not fun to visualize. So let me show you the wine thing. Okay, I have to change my screen once again. Okay, so observe that here. So here it's a wine, so you don't know the class identifier. Okay, here it's you're trying to understand the bivariate behavior. So let's take the x-axis to be flavonoids, and the y-axis to be, let's say, alcohol. And if you, oh, I'm so sorry, this should be this. Yeah, so let's say alcohol and then say flavonoids. So observe that it doesn't give you any information about how the data sets are behaving, whether like it doesn't give you any information about the clustering thing, right? But if you if you make a probability distribution out of it, you will get a lot of information about behavior, how similar behaving structure. So let's see how to visualize it. So scatter plot is therefore doesn't give you any behavioral understanding. That can give you other understanding, which I will tell you later on, but it doesn't give you any behavioral understanding, like how the two things are staying together and collaborating with each other to give you clustering information, to give you similar behavior information. So what does it give? It is given by, as I've shared with you, is a it's a contour plot. So I will show you the contour plot probably. So this is one example of the contour plot. You can see for total phenol and alcohol, it's you can observe that there are three almost clusters. Actually, in the actual data set, there are three clusters. So I did this, I did this clustering, and so I removed that data set. Okay, I removed that predictor data set, and I did a clustering on it. And the clustering result was as good as the supervised learning result. Okay, so that's the fun part. I did this project. I did this with my students too. So it was fun. So if you just remove the supervised learning thing, if you remove the y-axis and do the clustering and predict the test, the test data set corresponding different structure, you will see that this is fun. This is really interesting. That which turns out to be like clustering performs similarly. So the supervised learning thing, the extra information doesn't help you. Anyways, so this tells you that there are three clusters. You can see three modes out there. It's a probability distribution, okay? You can see three modes. It's a bivariate probability distribution. You have learned this in your, I guess, in your bachelor's. All of you know bivariate probability distributions, guys? I hope you know. So this is a bivariate probability distributions on total phenol and alcohol together, okay? And understand that this gives you three modes. It's similar like maximum likelihood estimation, okay? Where you get three modes and you estimate the modes from there. And this gives you information that probably there are three clusters, and actually there are three clusters. Okay. So all of you understood this idea of bivariate behavior, guys? For numerical versus numerical, it's not scatter plot, but it's this. You can also do it by contour plot, okay? So I will show you the contour plot right now. So it's a different data set. Let's trying out. Let's say alcohol here, and let's say total phenols here. You can see that the behavior out here, the three different kind of distributions. So these two are also modes, but these are not so important modes. The most important modes are like this, okay? So you can see three distinct behaviors out there. You can see you can check out other things also. Let's see malic acid and phenol. So and alcohol. It gives two information. Okay. So let's take magnesium now. Let's take magnesium and alcohol probably. And let's say ash. So it doesn't give any information out there, not too much information. There are actually 3 clusters out there. Okay, let's say pro this one. How does it give? No interesting information. It seems like only one. So what does it mean? Is magnesium and proanthocyanins, this together gives you no information about similar behavior. But if you take the idea of alcohol and let's say total phenols, or let's say flavonoids, okay, you can see that probably there are 3 behaviors. Let's take total phenol. So they will see that there are 3 behaviors out there. If you can take flavonoids and let's say color intensity, you'll also see that there are 2 behaviors, not exactly 3 behaviors. Okay, so did you understand, guys, that how this bivariate contour plot or bivariate density can help you in understanding the clustering behavior, similar clustering behavior, guys? Yes or no? Did you understand, all of you? If you have not understood, please let me know. Please tell me. I will help you out. That's great. So class scatter plot is not the way out. The bivariate density plot is the way out for understanding the clustering behavior. Okay, great. Okay, so if you have doubts, please ask me. I will give you some minutes to ask any doubt. If you have doubts, feel free to ask me, guys. Yeah, I'm just senior of yours, so you should feel free to ask me. Any doubt?
We will have to do this for all the variables to find the relationships.
So that's what my next point will be soon. That's a very good point. Who was this? Whose question was this?
Shubrika.
Yeah, hi Shubrika. So yeah, that's a very good, very good point, and I will attend this. So that's why this will be a bit longer. So that's a very good point. Yeah, thank you for mentioning that. Yes, and the answer is no. We don't have to do it.
Okay.
Yeah. And if you want to learn why you don't have to do it, you have to stay a bit longer because um, yeah,
Yes,
it will
yes.
be yeah. Yeah, thank you, Chuprika, for asking this question. So, hello, Deepam. Yeah. So, scatter plots is not used because for understanding the behavior, you cannot deduce anything from it. You cannot deduce behavior like clustering relationship from it. Okay, clustering relationship can be deduced by closeness, and this closeness and groupiness. Okay, the groupiness is not calculated by scatter plot. Scatter plot was used to, you will see, it's to find the relationship. Okay, and I will tell you that. But groupness is being, or togetherness is being calculated by probability density. So the more close it is, the higher peak of the probability density will be, right? If there are more data points in a single region, the probability distribution will be higher. So therefore, bivariate probability distributions or contour plot, the 2-dimensional view of probability distributions, will be useful for that. Okay, and that's why it's not used. But scatter plots is used. You will see why when. Okay, so let's see. Oops, where is it gone? Just give me a minute. Okay, so let me just. Oh yeah, got it. Yeah, so for example, here you can see it. Okay, you can also draw similar type of things. For here, it's 2 information. Here 3, there 2. So that's it. Yeah. So this is what I wanted to say, and yeah. So let's go back to the data set now. And just give me a minute. I couldn't find this. Yeah, got it. Okay, so this is a bivariate behavior. Okay, that now let's see some examples of categorical versus numerical. and how you can see some group behavior. So the categorical versus numerical is actually also showing yeah, so you can it's essentially also we'll see this coming up in the next aspect, the relationships. I will show that to you together. Okay, so another question Ayushi Pathak is asking, that only contour plot is used for such analysis. Yes, so I mean I use that. Okay, so this is what I do for my own thing. So my goal here uh, is that to reduce your list of data visualization techniques to understand based on your goal. Okay, so you can use other things too, but I use this because that's just used, like that's helpful for me, but you can do other things too. You can, so as I can tell, as I have told you before, or as shared to you before in that no BS guide to data visualization, is that you can add points to it. So I don't know what those are called, but essentially the core of this should be probability distributions. Okay, contour plots type. So do you have some other plots in mind? Maybe I can like explore that, Ayushi. Or it was just like a question. Okay, probably she will answer soon. So yeah, so now understand that what we will do in kind of bivariate relationship now. So what is a bivariate relationship? Understand there is no univariate relationship. For to have a relationship, you must have at least two, a pair, okay, a pair or more. So bivariate relationship means that to understand the relationship, rather a functional relationship between two set of variables. Okay, a functional relationship, or rather a qualitative understanding of the quantitative relationship. So for example, numerical versus numerical, scatter plot is very important because you can see the function out there. Okay, that's very important. I mean, at least a basic visualization. You can also visualize in higher dimensions, but not always you will get any relationship. Okay, but you will get at least a lead towards that. So scatter plot is the way out. So yeah, so the density plot, remember, will not give you any relationship idea from from the behavior, but scatter plot will give you. Okay. We have come to the domain of supervised learning. Okay, and for categorical, I will you have contingency table and group bar plot and stuff. And now what I will do, I will, before proceeding towards the next, showing you examples based on that, I will go to my notes and show you the basic ideas of like all the types of graphical plots. Okay, so that you get to know them in a detailed way. So yes. Okay, so let's go here and let's say, so let's take this case that, so essentially always when you're taking a relationship or you're taking bivariate something, there will be always these three kind of categories: for categorical versus categorical, categorical versus continuous, continuous versus continuous, okay, or numerical versus numerical. Continuous here means numerical. So for categorical versus categorical, let's say you have 202 data points, and it's a gender of a player and the sports the player plays. Okay, for the sex and the sport, you can draw the contingency table. Okay, and probably you can see that um, from the data set we get that males play more water polo than females. uh, Females play more netball than males. This b-ball, I don't know, probably it's baseball, they play the same type. Females do more gym than males. I don't know, like this is like the true or not. I think they're same. And you get, essentially you get some information out there, but you can a heat plot. Okay, so the heat plots will be equivalent to the amount of data inside that. Okay, the amount of data inside that, the more the number is, the more darker it will be. So this is the data, so you can understand it from here how the two variables, the two categorical variables are interacting with each other and whether it's giving any useful information or not. Now categorical like bird plots, you can also do the vertical bird plots like this, where for each of this each of this baseball, you can just plot like this. It's simple stuff. I'm just telling you the thing, you can do it later on. So it's a good visualization. You can see that this is equal netball is red. So more the green is, more one part is playing more. So the more the difference is, there is more difference. Okay, the more the Difference is there's more difference between the two categories and their numbers. So you can also do it by beside bar plot, and you can also get some ideas. Okay. So you can conclude something for categorical versus continuous. Let's take take an example of one continuous variable and one categorical variable. One is the hemoglobin concentration, one is the sports the player plays. Okay. And you do box plot. So now you remember box plot is done for a single univariate data set. Now what you do is that for each of the categories out there, let's say for hemoglobin, so for this sports versus hemoglobin concentration, for each of those baseball, field things, gym, netball, all of these things, you do a bar plot and you see how they behave. For example, you can get that field, those who play in the field or something like that has more hemoglobin concentration than who do the baseball. Rather, it's required to have more hemoglobin concentration. The people who have played netball, probably they have less hemoglobin concentration. Biologically, it is also can be a latent variable, because I'm not sure, but probably as I've heard from doctors that women tend to have lesser hemoglobin concentration than men. So probably this can be a latent variable in action also, but you get some idea that why it's happening. So essentially, you can understand each of the relationship between categorical variable and continuous variable using this grouped box plot. And I see it's everything is contained in this three type of scenarios. Categorical versus categorical, categorical versus continuous, continuous versus continuous. Okay, everything is contained in that. So there is nothing we are missing out. So for categorical versus categorical, we have seen continuous. We have seen this, and yeah, you can understand which sports demands more hemoglobin concentration than others. Okay, and that can result in that. Also, you can do kernel density estimation for each of these thing. For each of this, for each of these categories, you can do grouped kernel density comparison. Like this. For example, you can see the netball has a layer hemoglobin concentration that, let's say, this the other things, tennis or water polo or baseball, I'm not sure, like the bigger one, you can see this one. This requires more than this. Or the players who play that, there are more. This is much more like the middle one is much more, much more stable, much more balanced. And probably rowing has almost equal number of players, so that's why it's balanced and it's symmetrical. So this is the basic things you can understand for categorical versus continuous. You can do group box kernel density comparison, and you can get all the information out there. A good way to understand the data set. You don't need to do all the data visualizations out there. You can do the small things out there to understand what's happening. That's it. Simple stuff. Like a step-by-step algorithm, do it and understand it. If you cannot understand it, there's a next step out there, okay, which you can do. That's it. All of you understood this, guys? Then I will move on. For continuous is continuous, you have seen that scatter plot really helps for understanding relationship. But for unsupervised learning, you will see the this bivariate plots help. Okay, that's it. So that's the entire introduction to data visualization, guys. Okay, how to do for all possible cases, for both unsupervised and for supervised, all the cases. Okay, and that's the beauty of it. That's the simplicity of it. So I was really confused, because different people are doing so many different visualizations. Like I did not understand like which visualization to take and how to interpret the information out of it, because that's the goal, to interpret information out of it. And I'm happy that with experience I learned this, and that's why I'm so happy to share it with you. I hope this is the second part, the middle part. So I hope all of you understood it. Do you have any doubts, guys, regarding when to do what type of data visualization? Any doubt, you can ask me. I will wait for some time. Great. Thank you, all of you, for sharing your view. All of you. Okay, great. Super. So the next part of the next part of discussion is based on, so this is done. Thank you, Abhijit. Thank you, Shubrika, and others. So great. So this is the basic thing, and yeah, you can just see it. Okay, so let me just okay. So I will do the next one. I think that's probably more interesting to you. Now I will exactly go to Shubrika's doubt. Thank you, Deepam. Thank you, Deepam. Thank you, Deepam. So now you can also do trivariate relationship where you can use bivariate plus aesthetics like color, the size to have a 3D visualization idea. Okay. And that helps. That sometimes helps. Okay. That sometimes helps and help you understand that things. But the question is that which one to use when? And I have already told you that in supervised learning, we ask questions like how X1 affect Y, or how X1, X2 affect Y. So that's why you have bivariate relationship and trivariate relationship in supervised learning. But for unsupervised learning, we ask questions: is X1 associated with X2? By association means they are together or they are behaving similarly. Does X1 show clusters or X1, X2 show clusters together? And for that, so for association purpose, you can do relationship thing, and for clustering purpose or similar behavior purpose, we do the behavior thing, univariate behavior, bivariate behavior. That's exactly what we have shown here. Okay, great. Now the story goes like this: that you collect the data, now decide your goals, whether it's unsupervised learning or supervised learning, and then you visualize the behavior of the data or relationship with the data, and then from there you can ask questions. So probably from the pictures I showed to you, that flavonoids and total phenols probably are better features or probably give more clusters than others. Flavonoids give more clusters than magnesium. So these are the questions you ask. So, and that is very important because that's how it's being done. For example, I'm working with if you don't know, I'm working in neuroscience also, and I'm working in neuroscience and a machine learning team. I'm doing the machine learning and statistics stuff, so it's fun. So I'm trying to analyze MRI and all these ultrasound images and try to get some data out of it, understand and help medical people. So it's a collaboration in the medical team, and it's really fun out there. Okay, understand a lot of things. So currently we are working on some hydrocephalus in African kids. So that kind of probably after when we diagnose this, it's a new kind, new kind of. So essentially, you see some test thing, right? So if you see in reports, if you take blood test that okay, this is a bound. After this, it is bad. After below, it's good. How do you find a bound? That's done statistically. How? It's exactly like clustering. So you have two groups. One is good group. One is bad group. Like they're infected or they have the disease or some issue, and then you plot them. You will see two clusters out there, and you can find a middle point out there. Okay, that middle point is a report test. After this, statistically, it's found out that middle point is that. After that, it is good. Before that, it is good. So that's why doctors often ignore the marginal cases. So that's a statistical problem, and that's done by statisticians and statistics people like you. So similarly, in this hydrocephalus thing, we are trying to find out such boundaries where after this calcium, like there's certain parameters out there. So after that, this will be good. Before that, this will be good. So doctors can essentially take decisions. So so if you work in the biostatistics fields, guys, you will see that more than predicting, it's more about information, more about like Rancho Das Chanchan type of view towards, because they don't want to apply machine learning algorithm without understanding okay what's happening under, because the machine can have the ability to kill the person. Like let's say you decide how much amount of medicine to give to the patient based on a certain machine learning algorithm. So there's some case happening and the medicine is stopped giving, the machine stops giving the medicine and the patient will die. So the patient's life is at risk. We cannot allow that. So that's why it's very important to have understanding and what's happening inside, and I'm trying to contribute my own humble possible way to that group. Yes. So now the question that Shubrika asked, and it's really important, like if we have 100 predictors, okay, then what we do? Like what exactly do we do? Do we do around 100 plus visualizations? And the answer is no. And that's the fun part of it. The answer is no. And we will see how. It's just a one line thing, and not one model thing. And we will use a very specific model. Is that the goal is that to do the most important visualization. So to understand the most important visualization, you need to do that, because when you're presenting in front of your client, you will not tell him or her that, oh, I have done this and this is found. Like it's not possible for you, a human thing. So you need a model out there to understand which are the important features out there. And that's why we will combine decision tree, because we all think decision tree is a model for prediction, but it is a model, one of the most important model for data visualization and understanding most important features out there, and we'll see how. Now let's talk a bit about what is decision tree. So decision tree is nothing but you have a data set, and yeah, someone has that out. Okay. Okay.
Hello,
Pankaj, it will be great if you can just mute yourself.
sorry.
It will be great if you can mute yourself so that there's no background noises. Okay, so thank you. So understand that the whole idea of decision tree is nothing but creating based on conditions. Okay, that let's say the decision here is to understand which. So if you understand that predictor, some predictors were there, and there was wine type. Okay, now the decision here is to understand that which one will be the wine, which type of wine based on the condition. Okay, so it's like alcohol percent is more, that means it's Arabic wine. Okay, let's say I'm giving an example. Alcohol percent is less, that means it's probably French wine. Okay, and okay, so now probably French wine or some let's say some other kind of wine, Belgium wine. So now to understand the difference between Belgium wine and French wine, probably we need another variable. Let's say we need phenols, total phenols. So if phenols is greater than this, then it's Belgium wine. It's less than this, so it's it's a French wine. Or yeah. So understand condition one will be, let's say, alcohol percentage. Therefore, greater than certain quantity, less than certain quantity. Greater than certain quantity, yes, that means condition two, or no, then condition one. Something like this. Okay. And let me give an example. Let's say the day is like, these are the predictors: weather, temperature. This is a very important example on the website, on all over internet. So weather, temperature, humidity, and wind, all these conditions are there, and your decision is to make a play. So you have collected a data set after in the past years, past days, and you want to make a decision tree based on this. So the decision tree will output something like this: that if the weather is sunny, if the weather is cloudy, yes, you can always play. Okay, it's already like, if you see cloudy here is always yes, whatever is cloud is always yes. So when the weather is cloudy, you can always play. When the weather is sunny but it's too humid, probably you will not play, but if it's normal, then you will play. If the weather is rainy but it's too strong wind, probably will not play, but if it's very weak rain but rainy, you will probably play football. It's talking about football. Or yeah. So this is a decision tree. For example, you can also, you can use numbers to it. If the humidity, if you have numbers over here it was humidity is high low, but it can recommend numbers too. So if the humidity is greater than 75%, you can just understand high means greater than 75%, less means normal, and similarly here. Okay. So great. Probably
Hi, Sri. I have a doubt. What did you answer to the bivariate predictors thing?
I didn't get you.
Like,
Okay,
we were
one
talking.
thing. I think Komal has her mic on. Can you just mute yourself, Komal? It will be helping me to. I cannot hear properly. Shubrika's doubt.
Yes, so we were talking about if we have so many predictors, are we going to do it for a lot? Are we going to do it for every other predictor? So the answer was no. So what was the solution to that?
Yeah, I'm coming to the solution. We need decision tree for that.
Okay, okay.
Yeah, yeah. So I'm therefore explaining to you the decision tree. Okay. So we will see decision tree and data visualization. Okay. So how we are using that. So this is a decision tree, and this is exactly how we're gonna understand. We will not learn how the decision tree works, because that needs some more time. We will not be able to do that. But what we can do is that we can understand how to use this model to, how this works, and how to use the model to get better data visualization. Okay. Okay. All of you understood the basic idea of decision tree, guys? What is a decision tree? Okay. Great. Now the question is that how to use decision tree for data visualization, and for this I will use this example time. I will show examples to show you how it works. Okay. Okay. So let's do it again. So what I will do is that I will create a decision tree and I will tell you that which is the, so we'll get to understand which of the features is important here. So here the dependent variable is this. Yeah. So you can see over here, guys, you can take both of them, whatever is fine with you. Let's take this because it's easier to understand that. So the decision tree tells you that the first bifurcation is the most important data visualization. Okay, the first bifurcation, and then comes the next one, because it's based on like the most important visualization, like the most important feature is flavonoids, and then based on that it's color intensity, and then proline. So you can see these three variables automatically comes out to be important. If you treat it like this, it's flavonoids, proline, and hue and diluted wines. Okay, how much this corresponding thing is there. But you can understand that proline, so you can understand it from here. Proline, color intensity, flavonoids are, and other, those two things are the most important things. And you can just make it a bit longer too. It doesn't give you a thing, and you can see that it's really good approximate thing. Let's see if I can. Yeah, for this also same thing. The basic idea is therefore that the decision tree gives you that. So now how to interpret the decision? It tells you that, okay, the flavonoids is less than 1.6 and the color intensity is more than 3.8. So it's the type 3 wine. If the flavonoids is less than 1.6 and color intensity is also less than 3.8, it's type 2 wine. If flavonoids is more than 1.6 and the proline is less than 725, it's type 2 wine. If flavonoid is greater than equal to 1.6 and proline is greater than equal to 725 and color intensity is less than 3.8, then probably it's 1.6, which you can approximate 2. And for color intensity, the other case, it's 1. So you can easily see a very distinct difference between all these things together, right, guys? All of you understood this? Yes or no? So let's now do flavonoids and color intensity in our diagram, okay? So let's go back to this and let's do flavonoids and color intensity. And you can see these two distinct things coming up here, and let's see what this tells you. So it's think flavonoids greater than or equal less than 1.6. Let's take this portion, okay? The right hand thing of that. Flavonoids less than 1.6. So flavonoids less than 1.6. Where's flavonoids? Flavonoids less than 1.6. And proline, now it's based on proline. Sorry, I'm doing some mistake. Color intensity is less than 3.8 is 1 and greater than 3.8 is 1. So you can see that it's telling you this. I don't know where it's coming from, but it's telling you that flavonoids is less than 1.6 is this line, and color intensity is greater than or equal to 3.8 is 19. So this diagram is not showing you that how the two things are coming up. Probably what I guess is that probably it's because there's less number of data set over there. Okay, there's less number of data set in that region. But you can see that the 28%, you can see 7% is there for the less than thing. But for this region, I can see probably for color intensity less than flavonoids less than 1.6, color intensity more than that 3.8. You can see this region. the writer region, this forms one cluster, and that forms is 28% of it. You can see that this is really 7%, so it doesn't give you. So 2 is made up of 3 things, right? Understand this. 2 is made up of 3 things, like this 3. So 7% of it is not really visible out here. So the 3 part is mainly from here, the right hand side. Less than 1.6 flavonoids and more than 3.8 phenol, color intensity. That gives you this. Now let's do flavonoids and proline. Okay, flavonoids and proline. Sorry, flavonoids and proline. So if you do flavonoids and proline, let's see the thing. Flavonoids more than 1.6 and proline has 2 different things, less than 7. So flavonoids more than 1.6 and proline 725, that bound. Okay. So flavonoids more than 1.6. Oops, I did something wrong. The flavonoids more than 1.6. Okay. Here this part, and proline less than and greater than 700. Okay, so you can clearly see this cluster is one such cluster. So for flavonoids greater than equal to 1.6 and proline less than 725, there is 2. There is 2. So there is mostly 2 and 1 out here. And for flavonoids more than 7, like greater than equal to 725, understands very carefully. For flavonoids greater than equal to 1.6, that means this region, flavonoids greater than equal to 1.6 after this region, and less than equal to 725, it's 2. That means the most of the data, and you can see it's a lot of data out here, 30% data. So the most of the data is coming out from here, this region, the second cluster ka. 30% of the data is coming out from here. Okay, and you can see that so there are 2 things when you do doing clustering, guys. Okay, the 2 things are, it's not only you should have good similarity, but we also have good distance from each other. Okay, and second thing is that you should also have more amount of point to satisfy that. You know, for having a strong group of people, you need more people in that, you know, to do something together. That means the data is trying to understand. Here this you see it's a really dark thing, so this cluster is kind of behaving together. Okay, and understand, you cannot understand how many clusters are there, but you can understand that they are behaving together. Probably you will get an idea. You can use you're using your brain machine and visualization thing to understand at least what's happening under the skin. And this part seems to be like cluster, but this is really less number of points, so it's not really much impactful to be a cluster, you understand. But this is much impactful to be a cluster, less than 1.6. And sorry, I'm doing it again wrong. Something is wrong. Just give me a minute. Flavonoids greater than equal to 1.6 and less than 725. Just give me a minute. This thing is here. So flavonoids less than equal to greater than equal to 1.6 and okay. What I can see here is that flavonoids greater than equal to 1.6 and proline less than equal to less than 725. So it's probably showing not this region, but this region in action. So this clustering it's taking into account. Okay. So this is a problematic part when you have multiple predictors in action. Okay. This is a problematic part when you have multiple predictors in action. And okay, let's try to do this way, that flavonoids and color intensity, and just give me a minute. again. The 3.8 pound. I wish I could have done the 3.8, got that time. 3.8, yeah, 1.6. 1.6, 3.8, yeah, got it. Okay, so let's again check this out, okay? So there are two behaviors out here. Flavonoids, you can see 1.6, there is a one point there where there's a boundary out there, that decision boundary, 1.6 greater than 1.6, less than 1.6. And you can see color intensity less than 3.8, greater than equal to 3.8, okay? So if you delete the proline part, then alcohol is coming up. Okay, let's check proline part. So, okay, so let's come back. Let's just take flavonoids and proline together, okay? Let's check that. For flavonoids and proline together, for flavonoids it's 1.6, and for proline it's, sorry, for color intensity is 3.8. Yeah. So for flavonoids 1.6, so this is a flavonoids 1.6 bound, and for color intensity 3.8, this is a bound. Okay, so you can easily see that for color intensity 3.8 and flavonoid 1.6, this is a very strong cluster, single cluster out there. Okay, for understanding it again, for flavonoids less than or greater than 1.6 and color intensity for flavonoids greater than 1.6. This screen is a bit, just give me a minute. Why it's coming out every single time? Yes, probably this will be helpful. Yeah, for flavonoids 1.6 and color intensity, I'm just explaining it again, okay? Flavonoids 1.6 and greater than equal to 1.6, less than 1.6, and color intensity less than 3.8. And less than 3.8 is this region. No, sorry. Again, I'm sorry. I'm getting confused. This region, okay? For flavonoids, less than 1.6 and greater than 3.8 is this region. This is one cluster. The upper one is cluster number 3. This is cluster number 2 somewhere, which is very less portion. Now, if you see here, the judgment over here, let's not take this, let's take 1 and this 1.6. The color intensity less than 3.8 and less than greater than 3.8. For flavonoids greater than equal to 1.6. So for this region, and take the upper part. For the upper part, you can see it's 1. That means this region is 1 and this region is 1.6, which is probably 2. Okay, so what I mean out here is that you will not get exactly the entire information out here. There are some discrepancies out here, but the basic idea is that since it's giving a lot of accuracy out here, you can see, and it's giving a lot of information out here, you can get a basic understanding of which are the most important variables and what to visualize. So let's try to also do it using this pseudo-numeric thing, and let's try to do its proline. Let's take proline and flavonoids again here. Now it's a different outcome, and you can see 755 proline and flavonoids. So flavonoids and proline, let's take it. Okay, so it's saying that proline greater than equal to 755 and flavonoids greater than equal to 2.2. Proline greater than equal to 755 and flavonoids greater than equal to 2.2. So this region is giving region number 1. So this is a region number 1. This is a region number 1. Both of them greater. This is the region number 1. It is already, we have got that before. For less than 2.2 flavonoids, that means this region, not this region, greater than that, that means this region, it's not much. So that's why you can see there is 4% out here. And then now you need to see proline and diluted wines together now. Proline and diluted wines. So let's check proline and diluted wines. Okay, for proline and diluted wines, you can see that for proline less than 755 and diluted wines greater than equal to 2.1, it's 2. 755 and diluted wine greater than 2.1, it's 2. So this entire region is 2. This entire region behavior is for 2 cluster. For less than this, it's mostly 3. You can see it's just 4% of 2. For less than this, it will mostly be 3. If I take, yes, so you can see it's mostly be 3. If I take a smaller data, smaller tree length, it's it's making it more deep and deep. So that's why it was hard for you to understand. So again, for proline and diluted wine, you can see that this cluster is giving one data set and this cluster is giving one data set. Okay, and there's a simple boundary out there. You can easily understand that. And for flavonoids and chlorine, you can do and get the difference between 1 and 3. There's one big cluster out there for 1 and the rest is 3. So that's the basic idea. Okay, I hope all of you understood this. I hope it made it clear to you guys about which are the important data visualizations to do, which are the important factors to take into account from this. And of course, it's a hard thing. So that's why you will not get exactly very symmetrical structure, but you will understand that which data visualizations to do and what to present in front of the clients and what not to present in front of the clients. Okay. So of course, you will not go and present suddenly because there are so many data sets out here. You will not go and present, let's say magnesium and hue. So you will not get and present this. Probably they are mixed together. All the 3, 1, and 3 and all these things are mixed together. Okay, so you will not get any information, interesting information out there. But you can show and get there and tell them that, see, this is where the things are coming up. Okay, this is the factors important and these are factors which leads you to that. So I hope it made it clear, guys. Decision tree is really important aspect in understanding what's really happening. It's also understanding which are the most important factors out there. Okay. That it makes sense, guys. Do you have some doubts? Did you understand, all of you? Please say yes or no in the comment box. If you have some doubts, please ask me. I would love to answer your doubt. So step number 1 is doing the decision tree. Step number 2 is trying to understand which data variables are important and how to and hence once you know these data variables are important, you can use them as plotting. What about others? Did you understand? So yeah, this marks the end of the whole discussion session, and I have nothing more to share. If you have some doubts, you can ask me now. Yes. Also, in case you're interested in in talking to me after the discussion, and maybe some people are shy, so I usually give them my LinkedIn profile, so you can just get in touch with me. It'll be great if you can send me a text like this is me, I have attended your meeting. So yeah, you can send me a request out here. Send me a note out there that, hey, I have attended your meeting out there. So that will be, I will help you. It will help you to understand how to find digital variables in a very first look. You cannot find that because there are a lot of variables, Pankaj. But decision variables, you can, from the decision tree, you can understand it. Decision tree, the topmost one is the most important one. And then the so from here, you can understand the differentiating factor. So what this doing is that actually 1, 2, or all these things are, all these things are numerical. So it's trying to understand whether it's numerical or not numerical. Okay, so that's it. So if you do as nonce, it will assume it's numerical, it will not assume it's numerical. So this is what it's happening. Yeah. So it's giving 35% Y. So this is very interesting. This gives you the entire thing almost. It's giving 95% accuracy. So you can easily That's an interesting thing. So first step is to understand the decision tree, that which are the important variables, and then you plot them up in the using the map I have given you, the ways to do that, to understand what's happening. Okay, to uh, give only those decision, only those data visualizations. Okay. Okay, you have some doubts, guys? Any other doubt? I don't know. Like, I think Shubrika asked this. Is it clear, Shubrika, now?
Yes, yes.
Okay, great. Any questions out there, guys? Any doubts? Okay. Yeah, okay, I will just ask Siddharth. I have read some theoretical stuff about principal analysis, principal component analysis in graduation. Does it have any relevance out here? Yes. So all these things I'm sharing it to you, Siddharth, is that principal component analysis is nothing but it tries to find a direction, a mixture of all these quantities that gives you the most amount of information, the maximum amount of information. It gives you in a decreasing manner. So it doesn't have apparently, but underlying it of course may have. Like, you can do it out and see that probably as 2 times flavonoids plus 3 times proline has a more, it gives a maximum amount of information, and let's say 80%, 90% of the information. So yeah, I mean, all the things that we do are mainly about feature selection, finding out the most important features, because the question which Shubrika asked, that which are the important variables, that is a very important question to ask in data science. So because you cannot handle every data out there. So that's the part. Yeah, that's the idea. In which is done in neural networks. Okay, yeah, it's in neural networks something called so initially it's a huge big, it's reduced down to a lower size. Okay, so that this is called a lesser representation dimension, so that this is a rich dimension, like this is a lesser dimension which contains the information about this data set, and then this is used as predictor in predicting the rest of the stuff. So that's what is done in something called encoder decoder, yeah, in machine learning, in neural networks, deep neural networks. Yeah. So Deepam Thakur is asking, first categorize the data and then apply the technique. What do you mean categorize the data, Deepam? Can you share your idea? I didn't understand your question. I mean, the first step should be to categorize data. It's almost there, but the first step should be to understand what are the important variables out there. And decision tree is not only for decision making, but it also helps to understand feature information. Okay, feature importance, and then you find out the most important information out there. Okay. Okay. Any other doubts, guys? Any doubt? Any questions more? Yeah, interesting knowing. Oh, that's great. That's great. There are a lot of good books out there. You can read that. There's one interesting website. I am not remembering the website. Yeah, I'm sharing this website with you guys. This is helpful for you. It should be helpful for you. Learn. Oops. Okay, so those who are interested, they can ping me on LinkedIn. I can give that because I am not being able to share it here. There's some issue. So you can just send me a note that, hey, I am from Operational Research DU. Please send me the link for Neural Networks book. I will send it to you. I will accept your request and send it to you because I'm not finding it here. Just searching from another laptop. How does it help in developing the model? Okay, so yeah, it can be a whole different discussion, guys. So yeah, it's a different discussion. Let's not go into that. But it's nothing but an extension of linear, linear stuff, linear regression. It's a simple extension of linear regression. It's very simple, but it's fun. Any other question out there, guys? Ashish, Aishi, Abhijit, Aditi, Afif, Anamika, Ankita, Amvi, Ayush, Bhauk, Vavna, Dipam, Devangshu, Thayal, Harsh, Harshita, Jashandeep, Kartik, Komal, Lakshay, Latika, Mannat, Mayank, and Muskan. Okay, there are other people too, a lot of people. Okay, so do you have the doubts, guys? Like Bhavna, Deepam, yeah, Nirakli, Lava, Muskan, Pankaj, Payal, Piyush. Yeah, do you have any doubts, guys? I would love to help you out. Any questions out there for me? Okay, that's great. That's great. Okay, so good. Yeah. Yeah, that's it. So yeah, I mean, my final thing should be, so thank you for joining, and if you enjoy the session, you can write a boom in the comment box. If you want to get that, if you want to get in touch with me, you can get me on LinkedIn. That's it. That's what my, and thank you for calling me, and I know I hope you learned something from it. That's it. Thank you. Thank you, Aishi. Thank you. Thank you, all of you. Thank you. Thank you.
Thank you.
Yeah, so it will be great if you can, if you have recorded the meeting, it will be great if you can send me it. So yeah, thank you guys for joining. Thank you guys for your interaction. Yeah. Thank you. Sure, sure. Thank you. Thank you. Yeah, sure. Thank you. Thank you. Thank you, all of you. All the best for your data science journey. And all of your first year and second year included from DU operational research.
Yes, sir.
Okay, okay, okay. So all the best for your placements, and yeah, all the best. And I hope it helps in your journey. Yeah. Okay. So will I leave the session right now?
Yes, sir. Yes, sir. Thank you so much, sir.
Okay, okay. Thank you guys. All the best. Good night. Yeah. Bye bye.
Thank you, sir.
My pleasure.